this video, we're going to look at elimination reactions and redox reactions in organic chemistry. So elimination reactions, perhaps maybe the simplest of the types of reactions we go through. We'll just look at one example. And elimination is you are just removing something from your molecule. So for the most part, you're going from something that's tetrahedral to planar as well. So the example we look at is the dehydration of ethanol. So ethanol C2H5OH. We're going to dehydrate it, so we're going to remove the water, so we're going to end up with an alkene. So we're going to end up with ethene. This happens in the presence of an aluminium oxide catalyst. Okay, heat is also required as energy in order to remove this H2O. So that's what's being removed from your alcohol to form your alkene and plus H2O. Okay, so this is the structure. So we have ethanol. This H2O that is down here is what is being removed. And we'll just add it in here as well, just to see that they are on both sides. So that is why it's called dehydration. If you're dehydrated, you're lacking water. If you dehydrate something, you're removing the water from it. So that is your dehydration. And that is our example of elimination reactions. Okay, and next we are going to look at our redox reactions. So first we're going to look at primary alcohols. So when we look at primary alcohols and redox reactions, okay, primary alcohols are oxidized to the corresponding aldehyde, which can be further oxidized to the corresponding carboxylic acid. So if we take an example, we have ethanol as our alcohol here. Okay, it's oxidized. We can say it's oxidized because of the loss of H2 of hydrogen. And we can say it's oxidized over here because of the gain of oxygen. Okay, so that's more going back to a junior cert almost description of oxidation and reduction. Okay, the loss of hydrogen or the gain of oxygen. It happens with a sodium dichromate catalyst. And they are acidified. That's acidified sodium dichromate in order to supply H plus ions. Okay, that also happens in the presence of hydrogen gas. And over the course of this, sodium dichromate is an orange colour. Okay, it's an orange colour because chromium has an oxidation number of 6. Okay, it has an oxidation number of +6, chromium does. In the process of this reaction, okay, so that would be an orange colour. And in the process of this reaction, it goes to +3, which is a green colour. So this is one oxidizing agent you could use. You could also use potassium permanganate, so KMnO4, which we have used before. If we look at secondary alcohols, okay, in the presence of an oxidizing agent, it's oxidized to a ketone and no further. Again, happens with sodium dichromate as your oxidizing agent, okay, not as a not as a catalyst but as an oxidizing agent. Okay, so here we're going from propanol to propanone in this example. So they are oxidation reactions. So just to reiterate, I suppose, that these sodium dichromate are not catalysts, they are oxidizing agents. Okay, again we can say that this is oxidized because we have the loss of hydrogen. If we look at some reductions then, okay, carboxylic acids are reduced to the corresponding aldehydes and further to the corresponding alcohols. So we're just the opposite of what we were looking at the start when we had an alcohol going to an aldehyde, to a carboxylic acid. Okay, it happens in the presence of hydrogen gas with the nickel catalyst, and it is just the opposite of what we had at the start. Okay, so the loss of oxygen and the gain of hydrogen. So that is a reduction in both of those. Okay, so the word aldehyde comes from alcohol dehydrogenation. And formerly in the breathalyzer test, potassium dichromate crystals were used, and the extent to which they turned green was a measure of how much alcohol was in a person's blood. So maybe not the most accurate of measurements, but it, in its day, it played its part. Okay, so now we have an electronic system. Okay, there's an electric cell. The ethanol is oxidized to ethanoic acid at one of the electrodes. Okay, so then they apply a voltage, and the higher the voltage reading, the greater concentration of alcohol is in a person's blood. This is just an overview of our redox reactions to finish up. So oxidation and reduction.